vertical distance, yes? So we found from min to max, and then half that vertical distance was the amplitude. Shh. The period of the graph was how long it took to repeat itself. And then it would go again, and it would go again, and it would go again, correct? The basic sine and cos graph have the same amplitude and same period. Both cos and sine have an amplitude of 1, because they have a vertical distance of 2. Both sine and cos have a period of 2 pi, or 360, because that's how long it takes to repeat itself, because you draw it off the unit circle, which takes 360 or 2 pi to go. So, if I'm going to talk about, let's all put our pencils down, calculators down, everything down, we're just paying attention. Everyone's listening. No pencils in hand. Everyone, all right, welcome. Welcome, everyone. You're out. Amplitude, the vertical distance is between -1 and 1, so that's a distance of 2. Correct? Okay. Would any horizontal stuff change my amplitude? Shifting it to the right or the left, stretching it wider or narrower, flipping it in the y-axis or anything, would that change this? What's the only thing that can change this? Would moving it up or down make it taller or shorter? No, I'm literally just moving it up or down. Same height distance, correct? Same vertical distance. So what's the only thing, flipping it, wouldn't do anything, what's the only thing that's going to change it? The stretch. That vertical stretch is the only thing. So fun fact, write this down, the vertical stretch does stretch have a T in it? The second T, not the first T. This morning my heart was like, I feel like something's wrong, but I'm pretty sure it's...
It looks right.
Like sketch. Sketch.
Yeah, it looks really wrong without the T. Which one?
Not the first one. It would be stretch.
Stretch.
Which T?
Yes,
it just looked wrong for a sec there. I feel it is a T. It just sometimes when you write it, it's like you write something and it just looks wrong.
If you write it without the T, it looks really wrong. So
stretch. There we go. Okay. Your normal amplitude on a cosine sine graph is what? 1. If I stretch it by 3, what's it going to be now?
4.
What do we do when we stretch? What operation? Multiplication. Okay, cool. We started with 1. We stretch it by 3. It'll be 3, because 1 times 3 is 3. Thank you. Okay, now amplitude starts at 1. I vertically stretch it by a half. What's the amplitude now? Half. Cool. Okay, 1. I vertically stretch it by 10. What's it now going to be, my amplitude? 10. So what is my vertical stretch actually equal to? The amplitude. Yes. Double heart. Okay, vertical stretch equals amplitude because the original amplitude of a graph is 1. Vertical stretch is multiplied by 1. When you multiply anything by 1, it becomes that number, correct? So if your vertical stretch is 3, the amplitude is 3, because 1 times 3 is 3. Vertical stretch is 3/4, the amplitude is 3/4. Okay? Cool. We're just going to talk about that for now. We'll talk about period in a second. So, your trig equations are always in this form. Look at that. That's the form you want. If you don't know what form that is, oh, look at the bottom of your formula sheet. They nicely give it to you. Okay? A is your vertical stretch and reflection in the x-axis. B is your horizontal stretch, 1 over b, and reflection in the y-axis. C is your horizontal translation. D is your vertical translation. Yes? Cool, we have fun. You now have to write it in English. Thank you, baby Jesus. He didn't always do it. Okay. No, they still have to write these in French, right? Yeah. Okay. So, ready? So, our vertical stretch is which letter? A, B, C, or D? A. Now, B, if you look, B is located between sine or cos and x. C is located after the x within the bracket. D is at the back. Yes? Okay. So what is the vertical stretch on this one? Dose. Vertical stretch by a factor of what? About the what? About the opposite axis always, so it's about the x-axis. Let's go back to mapping. X, y is going to become x comma what? Reel back 2y. Okay, what is my amplitude? 2. What if my A value was negative? What would my vertical stretch be? The same value would be a 2. What does the negative do? Reflection in the x-axis, right? It doesn't stretch it anymore, and your amplitude is always positive, right? Okay, I want you guys to go through, what is the A on this one? 1. So does it have a vertical stretch right now? No, so I'm not going to write that. What's my amplitude? We'll do mapping after. We're just going to do first column, that one. We'll talk about horizontal in a second. What's the amplitude of this one? 1. Okay? I'm not sure why it goes 1, 4, 5. I don't know where 2 and 3 left. Okay. So vertical stretch and amplitude, same, correct? We agree? Same. Okay. Your period of your graph is 2 pi or 360 degrees. We talked about that yesterday because we draw the graph based off the unit circle. Correct? Cool. Okay, let's have a discussion. If I vertically stretch it, is that going to make it more wide or narrow? No. So the period still stays 2 pi. Graph gets super tall or shrinks, but this baby stays the same. Yeah? Okay, cool. Now I'm going to move it up or down. Did it change the period? No. Okay, cool. Now I'm going to reflect it. I'm reflecting it. You just can't see because I don't have a shirt on. I reflected it. About the x-axis. Did it change the period? No. Now I'm reflecting it about the y-axis. Did it change the period? No. Now I'm moving it right. I have to do opposite in my brain. Change the period. Left. Change the period. No! What's the only thing that changed the period? Peeps? What is this? Horizontal stretch. Big, narrow, big, narrow, big, narrow. Okay, listening. Riddle me this. The period. We're going to do degrees first because you seem to like that. 360. I horizontally stretched it by a half. What's the period? 180. Boom. Back to 360. I'm horizontally stretching it by 2. Okay, I'm going to write that was 360 times 2. 720. Boom. Yes. Okay, 2 pi. Get ready for it. Get ready for it. Stretching it by a half. Pi. Stretching it by 2. 4 pi. So, does the horizontal stretch tell you the period directly? Like if the horizontal stretch is a half, is the period a half? No. That is the B value. Okay, that's your period. That's not helpful. It's helpful in a step, but not there. Okay, so let's discuss this one. What is my B value? My B value is what falls between cosine and x. So my B value is a 1. So what is my horizontal stretch? Trick question. Non-existent. It's not being stretched, correct? So then obviously the period is 1. And then I just go put that B value in for period, and I'm super correct, and then, oh, it's not 1. What is the period if it hasn't been changed? 360 or 2 pi. I stretched it by 1, which means I multiplied by 1. which does absolutely nothing. So what is the period actually? 360 degrees or 2 pi. We're going to put both today. How you can tell is they give you a domain with it or your C value. So your horizontal shift, if it's 30 degrees to the right, it has a degree symbol. Or it might be pi over 6, then you know it's a radian. So it's your C value that tells you if it's in radians or degrees. If we don't have a C value, they'd have to tell you. Okay, cool. This one's being horizontally stretched by a factor of 3. Obvi. Always a horizontal stretch by a factor of 3. I just let that roll. I'm going. X's be crazy.
They're psychopaths.
Psychopaths. Yeah. So if we go from equation to words or mapping, what happens to our X's? They'd be crazy. They'd be changing. So we're going from equation here, to words. So it's going to be not 3, it's going to be a third. So horizontal stretch by a factor of 1/3 about the opposite axis. So it's about the y-axis. So the period was 360 degrees. The period was 2 pi. I am now multiplying by what? 1/3. So I go 360 degrees times 1/3, and I get 120 degrees. It got smaller. That's wrong. Oh, wait. When I divide, gave away the answer. When I multiply by 1/3, it's the same as dividing by 3. So it is getting smaller. And then 2 pi times 1/3 always throws people off. This is the easiest one. It's just 2 pi over 3. What would my mapping be for this one? So if I can either go from equation to mapping, and then this bad boy's being crazy, or I can go from words to mapping, and they're in the heart, so they stay the same. So my mapping is going to be x, y becomes what? 1/3, because if you use words and mapping, they're in a heart, they're the same. 1/3 x, comma y. The third column we'll deal with later. Not at this moment. You guys try 5, go. What is this? Horizontal stretch. Guys, why are you all talking? Stretch by a factor of 2 about the opposite axis, about the y-axis. Words and mapping are the same, so we get x, y becomes what x? If I have a 2 in words, I have a 2 in mapping, because x would be crazy. The period, we are multiplying by 2, correct? So it's going to be 360 degrees times 2, which is 720 degrees. And then 360, that is, what am I doing? Then 2 pi times, which is 4 pi radians. Okay, in summary, the period of y equals sine theta is what? 360 degrees or 2 pi. It's correct. The period of your basic cos theta is same. The parameter b in the equation y equals fb of x, where f of x equals sine x or cos x. So basically, you get f of x equals sine bx, or f of x equals cos bx. Results in a what? Horizontal stretch. By a factor of what? Of 1 over b. About the, guys, quit talking. About the y-axis. Make sure you're filling this in. This means B gives you the number of cycles in 360 for sine or cosine. So like if it times by 2, then you would actually get 720 before you cycle. You can also use, you can either multiply by the horizontal stretch, or you can divide by B. Why could you just divide by the B value from your equation? Because you're going to multiply by 1 over B to get the horizontal stretch back, right? If you divide by B, that's the same as multiplying by 1 over B. So you can either use P equals 360 over B, or the period, oh, it's right here, or the period equals 2 pi over B if it's in radians. So you can just use that formula, but then you're using the B value. Remember, in your equation you have an A, a B, a C, and a D. You're using the B value. If you use the horizontal stretch, you have to multiply, correct? Dividing by the B value or multiplying by 1 over B, which is the horizontal stretch, does the same thing. So you make the choice and stick to it. You either think, I'm going to always multiply by the horizontal stretch and just get my answer, or I'm going to divide by the B value from the equation. Remember, your equations are this: A, B, C, D, right? So the B is this from the equation. You make your choice and stick to it. All right. Go. Okay. What is the amplitude of this one? 3. What's the amplitude of this one? What's the amplitude of this one? 3. What's the amplitude of the fourth one? 1/2, because it's equal to the vertical stretch, so even though that's a -3 in front, we do not write -3, correct? Okay. Now we're going from equation to words, so we're going across that double-headed arrow, so it's going to, X's be crazy. So we're going to get a horizontal stretch by a factor of, what? 1/2 about the, what's my mapping for this one? X, Y becomes a 1/2 X, comma, 3Y. So my period is being halved. So what is it going to be in degrees? 180 degrees or pi. Okay, number 2. This one has a horizontal stretch guys, please stop talking. By a factor of what? 1/3 about the my mapping is X, Y becomes 1/3 X, comma 2Y. So the period is going to be 360 degrees times a third, or divided by 3, which is 120 degrees, or 2 pi times 1/3. Okay, the next one is a horizontal stretch. By a factor of about the XY becomes 2x comma -3y. All right. We're going to get 360 degrees times 2 is 720 degrees, or 2 pi times 2, which is 4 pi. This one has a horizontal stretch. By a factor of what? 4 about the y-axis. My mapping is xy becomes 4x comma 1/2 y. Okay, the table's talking a lot today. So we get 360 degrees times 4, which is 1440, or 2 pi times 4, which is 8 pi. Okay, example 2. Example 3, go.